Morphic resonance is the idea that there's a kind of memory in nature. The so-called laws of nature are more like habits. Each species has a kind of collective memory to which each individual contributes and on which it draws. So there's memory everywhere in all self-organizing systems. The universe isn't governed by a kind of cosmic Napoleonic code that was there at the moment of the Big Bang, but by habits that have evolved throughout the evolutionary universe as a result of natural selection. Successful habits get repeated and become more habitual, unsuccessful ones die out. Well, this is a controversial hypothesis. I first put it forward in my book, A New Science of Life. This is the third edition of A New Science of Life, recently published, which in the US has been retitled Morphic Resonance. And the fullest exposition of these ideas is in my main theoretical book, The Presence of the Past, Morphic Resonance and the Habits of Nature. This is a hypothesis, which means it's a guess about the way nature works. It's not a fact, because it's not yet an established fact that morphic resonance happens. In my opinion, it makes a lot of sense of the natural world. It explains a whole lot of phenomena better than the regular idea that the laws of nature are fixed and eternal. And it has many implications that enable us to interpret many phenomena in a different way. For example, morphic resonance plays a major part in inheritance. Genes are important. They enable organisms to make the right proteins. But that's what they do. They don't code for the shape of a face or the instincts of a spider or the ability of starlings to fly in murmurations in great flocks without bumping into each other. None of these things are made directly by proteins. The proteins are like bricks in a building or the cogs in a machine or something. They're part of something larger than themselves, and it's the way they're all organized that makes the difference. And that, I think, is what morphic resonance does through what I call morphic fields. In fact, it's known that genes account for only a small amount of heredity in most cases, and this is now called the missing heritability problem, and I think it's missing from the genes because a lot of it's happening by morphic resonance. It has many implications for understanding familiar phenomena like the similarity of twins. Morphic resonance depends on similarity. The more similar any two people are, the more they'll resonate with each other. And so identical twins, even if they're separated soon after birth, would continue to resonate with each other and show many similarities in their lives, not because these are genetically determined or programmed, as usually assumed, but because they're resonating with each other on the basis of similarity. I also suggest that our own memories work by morphic resonance. Our brains are similar to themselves in the past. We are more similar to ourselves in the past than we are to anyone else, which is why we resonate specifically with ourselves in the past and have our own memories. We're a bit like other people, so we also pick up collective memories from lots of other people. But morphic resonance, I think, helps to explain memory, which is usually assumed to be stored in physical traces inside the brain. Attempts to find those traces have failed over and over again, and I think the simple explanation is they're not there. Anyway, this is a very controversial hypothesis, needless to say. Some people opposed to it even denounce it as pseudoscience because it's not in science textbooks. Any new hypothesis is not going to be in science textbooks until it's been tested more and a consensus grows up that it really happens. And that's why a lot of my time and effort is spent in thinking about and trying to devise new tests for morphic resonance. There's already a lot of circumstantial evidence that supports it. For example, if you train rats to learn a new trick in Boston, Massachusetts, rats in Edinburgh, Scotland, and in Melbourne, Australia, should be able to learn the same trick quicker, just because the American rats have learned it. And actually, from a long series of experiments with rats in water mazes, exactly this phenomenon has actually been found. Large increases in the rate of learning that spread from Harvard to Scotland and Australia, and which didn't depend on the rats being descended from trained rats. All the rats of that breed seem to be getting better, and that's just what you'd expect with morphic resonance. The hypothesis also predicts that if you make a new chemical compound and you crystallize it for the first time, there won't be an existing form for that crystal, an existing lattice structure, because it's never happened before. But the more often you crystallize it, the easier it should get. And that indeed is what happens. New compounds get easier and easier to crystallize as time goes on, the more often they're crystallized. And it should be easier for people to learn things that other people have already learned. For example, computer programming or skateboarding or windsurfing should be getting easier to learn because so many people have already learned them. It's already known that standard IQ tests seem to have got easier to do over a period of decades without people getting any more intelligent. And this has been a big puzzle in the field of psychology. It's called the Flynn effect, after a psychologist called James Flynn who discovered it. And I think the reason is that not that people are getting smarter, they're not, but the tests are getting easier to do because so many people have already done them. The more that do them, the easier it should be for others to do them afterwards.